let's talk about two of nature's most powerful and, frankly, most terrifying phenomena, a flash of lightning and the shaking of an earthquake. For most of human history, our ancestors looked at these events and saw the anger of gods. But today, we're going to go on a journey from that ancient myth to modern science and really unpack the incredible physics behind it all. Because when you see a storm lighting up the entire sky, or you feel the ground literally tremble beneath your feet, the question we all ask is, why? What is actually going on here? Before we had science, all we had were stories. For thousands and thousands of years, a bolt of lightning wasn't just weather. It was a message, a sign, and usually it was seen as a pretty terrifying display of power coming straight from the heavens. And this idea, the wrath of gods, is exactly where our story kicks off. This whole explainer is about that journey, how we went from seeing an angry deity in the clouds to understanding the elegant and honestly beautiful laws of physics that are really at play. So, how did we even begin to chip away at this mystery? Well, funnily enough, the first clues weren't found in some massive storm. They were found in these tiny, everyday sparks. Static electricity. And what is just wild when you look at this timeline is the huge amount of time it took. We're talking 2,000 years. That's how long it took for humanity to go from noticing a little static cling with a piece of amber to Benjamin Franklin flying a kite in a storm and finally proving, hey, this stuff in the sky is the exact same thing. 2 millennia, just to connect those dots. Okay, so to really understand lightning, we first need to meet the main characters in our story. They're totally invisible, they're absolutely everywhere, and they follow some very, very specific rules. Let's meet the electric charges. So, let's make this simple. Think of them as 2 little characters. We've got Posy, the positive charge, and Negi, the negative charge, and they live by just 2 simple rules. First, characters that are the same, like 2 Posys or 2 Negis, they push each other away, they repel. But second, characters that are different, a Posy and a Negi, are drawn to each other. They attract. That is it. Seriously. Those 2 rules explain everything from a tiny spark you get from a sweater to a massive bolt of lightning. And this is a perfect example of rule number 1. You rub 2 balloons with a piece of wool, and they both get loaded up with negative charges. They become Negis. So what happens when you bring them close? They push each other away, just like you see here. Simple as that. Likes repel. And hey, if you want to see this in action, you can build a super simple version of something called an electroscope. When you touch that paperclip with something that's charged, that charge zips down to both of the foil strips, and now, since they both have the same charge, just like those balloons, they push each other apart. It's a perfect little detector for our invisible characters. All right, so we've met our tiny characters, and we've learned their rules on a small scale. Now, let's scale it all the way up. Let's get to the main stage and see how this all builds into a massive thunderstorm. So inside a thunderstorm, it is just chaotic. You've got these violent updrafts carrying tiny ice crystals way up, while heavier water droplets are falling down, and all this frantic bumping and grinding strips electrons away, separating our characters on a colossal scale. The lighter, positive Posies get swept to the very top of the cloud, while the heavier, negative Negis sink down to the bottom. And this creates this immense electrical tension. And eventually, that tension just becomes unbearable. The air itself just can't keep those negative charges at the bottom of the cloud separated from the positive charges on the ground anymore. A connection is made, and in an instant, bam! An electric discharge just tears through the sky. That is lightning. So we've pulled back the curtain on the sky, but there's another force out there, just as powerful, and it was once just as mysterious, that comes from deep within the Earth itself. So now, let's shift our focus from the clouds down to the crust and explore the story of earthquakes. So the key to understanding earthquakes is this. The ground under our feet isn't one solid thing. The Earth's crust is kind of like a cracked eggshell. It's broken up into these huge, continent-sized puzzle pieces we call tectonic plates. And these plates are constantly and very slowly drifting around on the molten rock that's below them. And these plates are always moving. They're grinding past each other, they're crashing into each other, and sometimes one even slides underneath another. These boundaries, the fault zones, that's where all the action happens. See, immense pressure builds up as these gigantic pieces of rock get stuck against each other. When that pressure that's been building up is suddenly released, the ground shakes. the power of that shaking is measured on the Richter scale. The huge earthquakes in Bhuj and Kashmir, they were both over 7.5, and that is an almost unimaginable release of energy. Now, this is so important to get. The Richter scale isn't linear. It's what we call logarithmic. That means a magnitude 6 earthquake isn't just a little bit stronger than a magnitude 4. No way. As you can see here, it has 1,000 times more destructive energy. The power just ramps up incredibly fast. Okay, so we've looked at the science behind these two immense forces. But here's why it all matters. Understanding them is what helps us prepare. Knowledge really is the first step to safety. For lightning, the rules are pretty clear. Get inside a solid building or a car. You want to avoid big open spaces and tall objects like trees because lightning is often attracted to them. And since lightning is, a massive electrical discharge, stay away from things that conduct electricity, like metal pipes or wired appliances. And if an earthquake hits, remember this. The real danger isn't the shaking itself, it's what the shaking causes to fall. That is why the mantra is always drop, cover, and hold on. Get under some sturdy furniture. If you're outside, get to an open area away from buildings. The whole goal is just to protect yourself from falling debris. All right, you've absorbed the science, you've got the safety tips, so now how about a final challenge to connect these huge ideas back to our everyday lives? Here's the first one. You have definitely experienced this, especially in the winter. You pull a sweater over your head and you hear that crackle, crackle, spark. What's going on there? That's right, it's the exact same principle as lightning, just on a super tiny scale. The rubbing of the wool against your other clothes or your body, it separates the charges. And that crackle you hear, that's the sound of our little character Negi making a tiny electric discharge, a mini lightning bolt, as all those charges rush to get back together. And for our final thought, we've looked at two very different forces, right? One from the sky, one from deep in the earth. So what's the one piece of advice, the one big idea that connects them both? Well, it's this. Knowledge transforms fear into respect. By understanding the science, we can replace that ancient terror with practical preparation. Because whether the threat is coming from above or from below, understanding what's really happening is always our greatest shield.